Good morning, everyone. As we gather here today for the first international conference on electronics communication and signal processing, ICECSP 2024, let us take a moment to reflect on the significance of this event. We request the audience to stand in honor of arriving guests. Please join us in welcoming them with a huge round of applause as they enter.
Our delegates are being honored with flower badges, symbolizing our appreciation and respect for their invaluable contributions. Their works have been instrumental in driving progress and excellence in their respective fields. As we prepare to welcome our esteemed guests, let's take a moment to celebrate the wealth of knowledge and innovation that this conference promises to bring.
Our journey today is not just about the exchange of knowledge, but also about building connections, fostering collaborations, and inspiring innovations that will shape the future of our industry. It is a celebration of our collective efforts, achievements, and an opportunity to set new benchmarks of excellence.
I request the audience to kindly welcome our esteemed guests with a huge round of applause. Before we begin, I also request the audience to kindly make sure that your mobile phones are either in switched off or in silent mode. Thank you.
I request everyone to kindly be seated.
Good morning, everyone. We, Manjot Kaur Chennai,
And Samantha Gupta,
final year students from NIT Delhi, are honored to welcome you all to the first international conference on electronics, communication, and signal processing 2024, being organized by the Department of Electronics and Communication Engineering at NIT Delhi. We extend a warm welcome to our Honorable Director, Sir, esteemed Chief Guest, Registrar Sir, distinguished guests, and experts from outside NIT Delhi, faculty and non-faculty members of NIT Delhi, participants and fellow mates. This conference marks a pivotal moment for our department and institution as we welcome leading experts and scholars from all around the world to share their insights and breakthroughs in the dynamic fields of electronics and communication engineering.
before we begin, let us now pay homage to the flame of knowledge, dispelling the darkness of ignorance and illuminating our path towards wisdom. Shubham karote kalyanam, arogyam dhana sampada, shattu buddhi vinashaya, deep jyoti namostute.
Which translates to, I bow to the light which brings auspiciousness, health and prosperity, which destroys the intellect's enemy. I request the dignitaries from the dais to kindly come forward for the auspicious lamp lighting ceremony. I request the dignitaries to kindly take their seats.
IIT Delhi, an institute of national importance, has consistently demonstrated a legacy of excellence and has established itself among the premier institutes of the nation. We have gathered here to embark on a journey of knowledge and innovation in the dynamic fields of electronics and communication engineering. We are obliged to have with us the benign presence of the following honorable delegates. As I introduce them to the audience, I request Professor Manoj Kumar, Dr. Manisha Bharti, and Dr. Ikmantra Basu to welcome our dignitaries with a flower pot. Dr. Shiv Kumar Sharma as our chief guest. I request the audience to Professor Binod Kumar Kanojia as our guest of honor. Professor Shashi Kumar Dhaiman as our guest of honor. Professor Dr. Ajay Kumar Sharma, Conference General Chair and Director, NIT Delhi. Dr. Sudhesh Kumar Yadav as a guest of honor. Professor Jyotish Malhotra, Registrar and Dean RNC, NIT Delhi. Professor Sudeep Das Gupta as keynote speaker from IIT Roorkee. He will join in a short while. Professor Jasdeep Kaur Dhanwa, Vice Chair, IEEE Delhi Section from Indira Gandhi Delhi Technical University for Women.
Thank you so much, dear dignitaries. As we move forward, it is time to celebrate and honor the distinguished guests who have enriched us with their presence today. To start with, I invite Professor Dr. Ajay Kumar Sharma, Director, NIT Delhi, to kindly step forward for the felicitation ceremony. I request Director Sir to kindly felicitate our chief guest, Dr. Shiv Kumar Sharma, National Organizing Secretary, Vigyan Bharati. Shiv Kumar ji was born and brought up in Kolkata. He has completed his PhD from St. Xavier's College in Chemistry, after which he decided to dedicate his life for the nation building. He is a member of Rashtriya Swayam Sevak Sangh and has worked in several places all across India. Next, I request Director Sir to kindly felicitate Professor B.K. Kanojia, Director, NIT Jalandhar. His unparalleled contributions to academia have significantly advanced the field. His dedication and expertise have shaped countless innovations and guided numerous scholars. May I kindly request Director Sir and Professor B.K. Kanoja to please take their seats.
Next, I invite Professor Manoj Kumar, Conference Chair and Dean Faculty Welfare, NIT Delhi, to kindly step forward for the felicitation ceremony. I request Professor Manoj Kumar to kindly felicitate Dr. Sudhesh Kumar Yadav, Director CSIR, Institute of Himalayan Bioresource Technology, Palampur. Dr. Sudhesh Kumar is an exceptional scientist whose groundbreaking work in metabolic engineering, synthetic biology, and bioprocess technology has earned him prestigious achievements. I request everyone to kindly give a huge round of applause. Now I request Professor Manoj Kumar to kindly felicitate Professor Shashi Kumar Dhiman, Vice Chancellor, Himachal Pradesh Technical University, Hamirpur, a visionary leader and esteemed scholar whose contributions to nuclear physics and education have exemplary and reflects his unwavering commitment to advancing knowledge and nurturing future scientists. I request Professor Manoj Kumar to kindly take his seat. Next, I invite Dr. Manisha Bharti and Dr. Rikmantra Basu, Conference Organizing Secretaries, to kindly step forward and join Professor Manoj Kumar for the felicitation ceremony. I request Professor Manoj Kumar, Dr. Manisha Bharti and Dr. Rikmantra Basu to kindly felicitate Professor Dr. Ajay Kumar Sharma, Conference General Chair and Director, NIT Delhi. Director Sir's leadership has been instrumental in guiding the Institute's operation and strategic direction, fostering an environment of academic excellence and innovation. Now I request Professor Manoj Kumar, Dr. Manisha Bharti and Dr. Rikmantra Basu to kindly felicitate Professor Jyotish Malhotra, Registrar and Dean Research and Consultancy, NIT Delhi. Sir's extensive experience and leadership have significantly advanced academic and research standards. His active role in enhancing the teaching learning process exemplifies his commitment to fostering innovations and excellence at NIT Delhi. Now I request Professor Manoj Kumar, Dr. Manisha Bharti and Dr. Rikmantra Basu to kindly felicitate Professor Jasdeep Kaur Dhona, Vice Chancellor, IEEE Delhi Section from Indira Gandhi Delhi Technical, Vice Chair, IEEE Delhi Section from Indira Gandhi Delhi Technical University for Women. With notable roles including Dean Academic Affairs and Training and Placement Officer, she actively advocates for technology and student development. She holds key positions in IEEE and supports women in big data initiatives.
Next, I request Professor Manoj Kumar, Dr. Manisha Bharti and Dr. Rikmantri Basu to kindly felicitate Professor Sudev Das Gupta, a leading figure in microelectronics and VLSI at IIT Roorkee. With a distinguished career marked by over 250 research publications and significant contributions in the fields of artificial intelligence and machine learning, and also nanoelectronics, his work has had a profound impact on modern electronics. With this, we conclude with the felicitation ceremony. I request all the dignitaries to kindly get seated. We are privileged to host a distinguished panel of guests for the first international conference on electronics, communication, and signal processing, ICECSP 2024, to offer a comprehensive introduction and elucidate the importance of this conference. I now invite the conference chair, Professor Dr. Manoj Kumar, to share his insights and perspectives. Please, sir.
Thank you, Manjot, and good evening, everyone. Distinguished Chief Guest, Dr. Shiv Kumar Sharma, National Joint Organizing Secretary, Vigyan Bharati, Honorable Director and Conference Journal Chair, Professor Ajay K. Sharma, our guest of honor, Professor Shashi K. Dhiman, Vice Chancellor, Himachal Pradesh Technical University, Hamirpur, Professor Binod Kumar Kanojia, Director, National Institute of Technology, Jalandhar, Dr. Sudesh Kumar Yadav, Director, CSIR, Institute of Himalayan Bioresource Technology, Palampur, Professor Manju Bala, in absentia, Principal and Director, Khalsa College of Engineering and Technology, Amritsar. Our keynote speaker, Professor Sudev Das Gupta, Professor in Department of Electronics and Communication Engineering, IIT Roorkee, Professor Yo N Cheng, National Chung Cheng University, Taiwan, Professor Jasdeep Kaur, Vice Chairperson, IEEE Delhi Section and Professor in IGDTU, New Delhi, Professor Jyotish Malhotra, Dean Research and Registrar, NIT Delhi, other deans, head of the departments, invited guests, session chairs, esteemed faculty, colleagues, non-faculty members, participants connected through online mode or present in person, and my dear students. It is my honor to welcome you all to this first international conference on electronics, communication and signal processing, ICECSP 2024, which is being organized by Department of ECE, NIT Delhi. On behalf of organizing committee, I want to extend our warm welcome to each of you for being here today. Your participation is testament of your dedication to advancing fields of electronics and communication engineering. The conference theme of addressing the challenges and innovation in electronics, communication and signal processing reflects our commitment to exploring the cutting-edge developments and critical issues shaping these important areas. Over the next 3 days, we will involve ourselves in a series of enlightening sessions designed to explore the latest research, technologies and methodologies that are redefining our academia and industry. The conference received an impressive total of 651 paper submissions from researchers around the world. After rigorous review process, 240 of these papers were accepted, reflecting the high standards and quality expected by the conference committee. Ultimately, 159 papers were registered for presentation at this conference. The participation of researchers from different states of our country and abroad underscores the international significance of the conference and its role in fostering collaboration, innovation across the borders. The conference has 4 tracks. Track 1 is dedicated to microelectronics and system. This track offers insights into cutting-edge research and application shaping the future microelectronics. Key topic of this track include analog and digital circuits, integrated circuits, microelectronics and nanoelectronics. Track 2 is focused on communication system and networks, which is the backbone of our connected world. This track is essential for understanding the technologies that enable seamless, secure and efficient communication in our present world. This track will cover wireless and mobile communication, optical communication, network security, Internet of Things. Track 3 focus on signal and image processing. This track comprises a broad range of techniques and applications that transform raw data to meaningful information. Key area under this track are signal processing techniques, image processing, machine learning, real-time processing. Signal and image processing continue to transform how we perceive and interact with the rest of the world. Track 4 is dedicated to VLSI technology and embedded system. This track covers the critical technologies and methodologies that cultivate the development of complex, high-performance integrated circuits and their integration into embedded systems. Key area under this track are VLSI design and fabrication, embedded system design, system on chip and FPGA. All 4 tracks are designed to provide comprehensive overview of current trends and future direction in their respective field, fostering knowledge exchange and collaboration among researcher, academia and industry. We have total 18 sessions for the presentation of these 159 papers. The session chair has been invited from reputed institute and organization like CSIR National Physical Laboratory Delhi, IIT Roorkee, DTU Delhi, IG DTU Delhi, IIIT Una, Guru Gobind Singh Indraprastha University Delhi, NSUT Delhi, Jawaharlal Nehru University Delhi, Jamia Millia Islamia Delhi, D. Crust Murthal and Thapar Institute of Engineering and Technology Patiala. We are delighted to have 2 keynote speakers, Professor Sudev Das Gupta from Department of ECE, IIT Roorkee and Professor Yo N Cheng from National Chung Cheng University, Taiwan. Each of the keynote speakers is pioneer in their field. Their expertise spans from communication technology to novel approaches in signal processing and electronics. Their insight will not only inspire us, but also provide a deep understanding of current trends and future direction in our fields. Conference program is carefully designed to offer broad spectrum of conference content. You will find a rich array of technical sessions and keynote lectures. These have been selected to foster knowledge exchange, stimulate innovation, and addressing both foundational and emerging challenges. I encourage you to actively participate, ask questions, and engage in discussion that will help us to gain new outlooks and solutions. Engaging with your peers not only help to build professional relationship, but also foster potential collaboration that can lead to groundbreaking advancements. The journey of organizing this conference, such as is not an endeavor of one person. It requires collaboration, support, and dedication of many stakeholders. At this convergence, I would like to extend our sincere gratitude to different individuals and groups whose contribution have been instrumental in making this conference a reality. First of all, I would like to take a moment to acknowledge and appreciate Shri C.K. Birla, Chairperson, Board of Governors, NIT Delhi, for exceptional leadership and unwavering support to this conference. I extend my sincere gratitude to our Honorable Director, Sir Professor Ajay K. Sharma, for his guidance and support. Your leadership and guidance have been significant throughout the planning and execution of ICECSP 2024. We are truly fortunate to have a director who is passionate about progress. Today we are grateful for the presence of our distinguished chief guest, Dr. Shiv Kumar Sharma, whose support and participation has elevated this conference to new heights. I extend our deepest gratitude for taking the time out of your busy schedule to join us. Welcome, sir. I extend a warm welcome to Professor Shashi K. Dhiman, Vice Chancellor, HPTU, Hamirpur. We are honored to have you with us today. I am also delighted to welcome Professor Binod Kumar Kanodia, Director, NIT Jalandhar. Your presence here signifies your commitment to fostering innovation and excellence in engineering education. We are also privileged to have us with Dr. Sudesh Kumar Yadav, Director, CSIR, Palampur. Your expertise and insight are invaluable to us, all of us gathered here. Furthermore, I am honored to welcome Professor Manju Bala in absentia, Principal and Director of Khalsa College of Engineering and Technology, Amritsar. We are grateful for your presence and look forward for your insight. The organizing committee extend our heartfelt thanks and sincere appreciation to our esteemed technical sponsor IEEE Delhi section. We are thankful to Professor Jasdeep Kaur, Vice Chairperson IEEE Delhi section, Professor Abdul K. Ansari from Jamia Millia and from IEEE Delhi section. The IEEE Delhi section has played an instrumental role in ensuring the technical excellence and integrity of our program. At this point, I would like to extend a special thanks to our financial supporter, Antupel Technology, for being our gold supporter for this conference. I extend our sincere thanks to KCET, Amritsar and ITENX for their support to this conference with a conference dinner to be scheduled on 9th August 2024. We are also thankful to Silicom Electronics Private Limited for financial support to this conference as a bronze supporter. We are thankful to ARK Info Solution Private Limited for being our bronze supporter for this conference. We also appreciate the financial contribution by Trinity Microsystem to this conference. The commitment of all our supporters to promote research and development in electronics, communication, and signal processing is highly appreciated. We value your contributions and support and look forward for continuing collaboration in near future also. I am thankful to esteemed speakers, authors, panelists, reviewers for dedicating your time to this conference. A special thanks to organizing committee and whole complete Department of Electronics and Communication, teaching and non-teaching staff, all volunteers who have worked tirelessly to bring this conference into reality. In closing, I want to express my sincere appreciation for your participation and engagement in this conference. Your presence here is valuable contribution to the advancement of our field. Let us take this opportunity to learn from each other, explore new ideas, and foster meaningful collaborations. I wish you all a productive and inspiring conference. May ICECSP 2024 be a milestone in our collective aim of knowledge and innovation. Thank you once again for being here. Enjoy the conference for next 3 days. My best wishes for the conference. Jai Hind, Jai Bharat.
Thank you very much, sir, for giving an overview of the conference. Next, please join me in welcoming Dr. Rikmantra Basu, Head of the Department of Electronics and Communication Engineering, and the Organizing Secretary of the conference, to the stage for a brief overview of the department.
Thank you very much, anchors. Good morning, everyone. Honorable Chief Guest, Honorable Director, Sir, of NIT Delhi and Conference General Chair, respected guests of honors, the Registrar, the Conference Chair, my other Conference Secretary, other respected dignitaries on and outside the dais, all designated officials from IEEE Delhi section, technical financial supporters, all participants across various parts of the country, faculties and staff members of NIT Delhi, ladies and gentlemen. The chairman has already given you a very brief introduction to this conference and extended a hearty welcome to all of you. The pleasant duty to briefly present the activities of this Electronics and Communication Engineering Department now rests on me, which I will try to give me a very brief summary of that. There are total 13 faculty and 4 technical staff members in the department. All of them are very academically active and enthusiastic. The department has so far produced 31 PhD scholars who are well placed in various organizations across the country, and presently 43 more scholars are working in this department towards the degree. At present, the department is offering 2 BTech programs in EC and VLSI Technology in Design, and also MTech programs in EC and VLSI Designs, with tentative strength of 195 BTech students and 45 MTech students. The total number of journal publications by the faculty in this department so far exceeded more than 700, and more than 450 conference publications have been published. Faculties have published more than 7 books, completed or continuing more than 5 research projects funded by DST, CSIR, and many other reputed agencies. They are constantly giving invited talks and working as experts in different committees and acting as reviewers in many international journals. The BTech and MTech degree holders as well as the PhD holders find their jobs in India and abroad. Our department has active collaboration and engagement programs with the CSIR National Physical Laboratory, NILET, Synopsys, MAITI, Government of India, International Science Academy, DST Serb, National Chungcheong University of Taiwan, etc. And we are pleased to state that this department arranges regular workshops, conferences and tutorials, among which many are IEEE supported workshops and short-term courses. However, after a very long time, we get privileged to organize a truly international and such a wide level of conference, which is undoubtedly the brainchild idea of the conference chair, Professor Manoj Kumar, and under whose guidance we all have started preparing almost a year ago to stand in front of you today. The present ICECSP 2024 signifies another milestone activity of the department in collaboration with IEEE Delhi section and many IEEE society chapters under Delhi section with other many organizations. I sincerely hope that the present conference will lead to very useful interaction between the participants and among us, and may lead to fruitful collaborative academic program in near future. We are really thankful to all our participants of this conference, session chairs, and all those who took active interest. We admit there are many lapses in making your stay or other few arrangements, but regarding participation during these days. However, we offer our sincere apologies in advance, but hope in spite of our limitations, this conference will give you a platform for mutual exchange of ideas and new academic and research collaborative friendship. I extend a very best wishes to all of you. Thank you very much. Thank you.
Thank you so much, sir. Next, we are thrilled to hear one by one from our esteemed guests of honor. It is with great pleasure that I invite them to share their insights with us. Please join me in welcoming Dr. Sudesh Kumar Yadav, Director, CSIR, Institute of Himalayan Bioresource Technology, Palampur, HP. Please, sir.
A very good morning to one and all. Namaskar. I extend my thankful to Professor Ajay K. Sharma, who has invited me and given me opportunity in this very important conference, which is, I heard that this is the first conference for this very important National Institute of Technology in Delhi. And I feel thrilled to be here among youngsters, particularly whenever such programs are organized. The very first purpose of organizing this kind of events is inculcating that environment and giving that opportunity to our young generations so that they can learn out of these conferences that how they are important and what are different kind of events are being organized in a systematic way, and they are the futures that how they will take it further. Honorable Chief Guest of this conference, Dr. Shiv Kumar Sharma ji, other guest of honor sitting on the dais, and very eminent personalities sitting in the auditorium of the dais, and the young generation sitting in this hall. This conference is actually on electronics and communications, and I belong to an institute who is Council of Scientific and Industrial Research, and there are 38 laboratories across India. This is one of the organizations which was established before independence, and the founder Director General of CSIR was none other than Shanti Swarup Bhatnagar ji. You might be aware that Shanti Swarup Bhatnagar Award is being given to one of the most accomplished scientists in the country who is expert in their field. The IHBT is one of such laboratories and the alone scientific organizations in Himachal Pradesh. It is at a very beautiful place, Palampur, which is in the lap of mountain, which is known as Dhauladhar mountain, which is covered with white snow. The environment is very beautiful, and we have been working in the area of bioresource technologies, and in that we have 5 departments for the knowledge of younger generation. We are working in biotechnology area, environment technology, agrotechnology, chemical technology, and food and dietetics nutrition technology. These are the 5 different areas, and we have been exploring the bioresource of that region is the primary mandate. But we are not restricted only to that. If we consider the present scenario that we need to develop technologies around these kind of bioresources and we take them further, we create startup ecosystems, we have the incubation facilities, developing technologies, the infrastructure which is required for the industry to develop products around these kind of bioresources. So these kind of facilities are existing there. As I heard, this conference got a very good response in terms of the participants. More than 600 participants applied for this and they successfully got 250, and then ultimately 150 speakers would speak during the conference in next 3 days or so. I extend my warm wishes for the successful conductance of this conference to the organizers and particularly to the director of this institute who has started this culture in this organization, and I am very hopeful that this would lead a very fruitful for the younger generations, and they will learn a lot of things from their colleagues who will be presenting during this conference. Thank you so much for giving me this opportunity, and all the best.
Thank you, sir. Next, I would like to welcome Professor Shashi Kumar Dhiman, Vice Chancellor, Himachal Pradesh Technical University, Hamirpur.
नमस्ते सबको मेरी तरफ से. I should hear some voice from the back benchers at least. नमस्ते. So हम एक दूसरे का अभिनंदन करना चाहिए जहाँ भी हम मिलें. So we should you see embrace everybody. So आज के इस कार्यक्रम के मुख्य अतिथि माननीय डॉक्टर शिव कुमार शर्मा जी, राष्ट्रीय संगठन मंत्री विज्ञान भारती, my distinguished colleague sitting on the dais, Professor Ajay Kumar Sharma, Director NIT Delhi, Professor Vinod Kumar Kanojia, Director NIT Jalandhar, Professor Sudesh Yadav ji, Director CSR Laboratory at Palampur, Professor Manoj Kumar ji, Chair, Conference Chair, Registrar NIT Delhi, distinguished colleague sitting on the off dais, and participant of the program, speakers, and young students. I think I can see that most of young students are also participating in this conference, and this is the first of its kind being conducted by this institute. So I come from university, which is Himachal Pradesh Technical Universities, which has a very small campus at Hamirpur, recently started. And it was started as a affiliating university way back in 2011. And entire technical education imparting institution in Himachal Pradesh are affiliated with Himachal Pradesh Technical Universities. So this is, you see, is a very small and brief profile of my universities. We have roughly 25,000 students, and each year we, you see, trained and award roughly 5,000 degrees to graduating engineers, pharmacists, then MBAs, MCAs, and so on. So as Professor Sudesh, I think, shared his views, and he told that such conferences are very, very important and relevant. It is, of course. But you see, if we go back to the history of this soil, Bharatvarsh, then we find that in ancient Indian times also, this civilization is, you see, leading its life or practicing its life in a scientific way. And those scientific, you see, the findings of ancient Indian period is, you see, put in the form of Vedas, Sutras, Upanishad, and so on. So you can find out, even today there are certain, you see, libraries. INSA is very close library in the Delhi, where you can find out such literature is available. Scientific literature is, historical literature is available in science and engineering, and you can just learn from there. So you see, this civilization is very, very advanced in physical sciences, chemical sciences, mathematical sciences, architecture, civil engineering, mechanical engineering, metallurgy, and so on. And if I come to the modern age, in modern age also, you see, we have so many leadership, scientific leadership, which works in the area of science and engineering, and one of them is Professor J.C. Bose. J.C. Bose works in many areas, but he works in wireless communication also. So he basically, you see, able to demonstrate his invention in 1894 for microwave radio telegraphy. And I think those who are in the area of electronics communication, they have full understanding. And later year, I think it was also, the same concept was also done by some another Macroni. But recently in 1997, the work of J.C. Bose was again recognized by IEEE, I think. This is what is, we are holding conference here, and he was now known as father of wireless communication. But you see, with the recent advent in technologies, any advancement, and those advancements are always influenced by artificial intelligence and its verticals, like your machine learnings, then computer vision, and reinforcement learnings, data learnings, and all these things. And in this conference also, I can see that as we talk about VSLI, then this designing of VSLIs are also impacted with the recent trends of artificial intelligence and machine learnings. These tools are very useful for the young people. I think they should get inspired and use them to provide efficient technologies for the use of mankind. And with these thoughts, I would thank the Director NIT for inviting me and for executing MOU with Himachal Pradesh Technical Vishwavidyalaya for future, so that we can have academic exchange with NIT Delhi. Thank you very much.
Thank you so much, sir. Next, I would like to invite Professor Binod Kumar Kanojia, Director, Dr. Bhimrao Ambedkar National Institute of Technology, Jalandhar. Please, sir.
So good morning to everyone. So I thanks organizing committee of this first international conference as well as Professor Ajay Sharma ji, because he is a director of NIT Delhi and he is also a faculty member of NIT Jalandhar. So always we have taken the guidance of Professor Ajay Sharma to execute of run of NIT Jalandhar. So thank you very much Professor Ajay Sharma sir, and our chief guest Dr. Shiv Kumar ji, Joint Organizing Secretary of Vigyan Bharati. So role of our India, how we will go towards of Vigyan and how we will enhance our student towards of a different innovation as well as a different culture of India. जैसा कि हम लोग जानते हैं कि हमारे ऑनरेबल प्राइम मिनिस्टर जी का एक विजन है विकसित भारत, लेकिन विकसित भारत हम लोग तभी ला सकते हैं अगर इंडिया के हम लोग और हमारे जो चैलेंज है साइंटिस्ट के लिए और फैकल्टी के लिए और स्टूडेंट के लिए, हम लोग जाते हैं कुछ परचेज करने के लिए, हम टाइल्स परचेज करने के लिए जाते हैं और कहते हैं ये इटालियन टाइल है, ये इस कंट्री की टाइल है, और परचेज करके लाते बड़ा खुश होते हैं. इफ वी डेवलप ऑफ अ टेक्नोलॉजी इन सच ए वे, बी प्राउड ऑफ दिस मेक एज इन इंडियन, then we can contribute as a Viksit Bharat. So I think that we should involve in a such a way to develop a technology and innovation, so we will proud as a this should be a Indian. इसमें क्योंकि भाई साहब बैठे हुए हैं तो इसमें कई चीजें हम थोड़ा शेयर करना चाहते हैं और रिक्वेस्ट भी करना चाहते हैं कि कई चीजें ऐसी होती हैं कि हम लोगों को विकसित भारत में हमारे बहुत लोग करते हैं. जैसे प्रोफेसर शशि दीवान जी ने बोला कि हम लोग देख रहे हैं कि हम मोबाइल और गैजेट का बहुत यूज कर रहे हैं, लेकिन सर जेसी बोस ने जो इन्वेंशन किया था उसी की वजह से कर रहे हैं, लेकिन हम लोगों को नहीं मालूम है कि सबसे पहले किसने स्टार्ट किया था. माइक्रोवेव का जो इलेक्ट्रोमैग्नेटिक सिग्नल का एक कम्युनिकेशन है वो किसने स्टार्ट किया था? सर जेसी बोस ने ही सबसे पहले स्टार्ट किया था इंडिया में नहीं वर्ल्ड में. जो सबसे पहले कम्युनिकेशन हुआ था इलेक्ट्रोमैग्नेटिक सिग्नल का जेसी बोस ने ही किया था, जिसका हम लोग गैजेट पे यूज करते हैं. और डिफरेंट आप गैजेट मोबाइल फोन हो और आपका लैपटॉप हो और जिसमें कम्युनिकेशन कर रहे हैं, जो हमारे ही इंडियन साइंटिस्ट ने किया था, जिसको हम बहुत कम लोग जानते हैं. ऐसे कई ऐसे इन्वेंशन हैं जो हमारे इंडिया में हुए हैं और जितना हम लोगों को जानना चाहिए उस हिसाब से नहीं जानते हैं, जैसा मेरा मानना है. हम लोगों का कई ऐसे हैं कि मैं देख रहा हूं कि मोस्ट ऑफ आवर यंग स्टूडेंट इज सिटिंग हियर और यंग फैकल्टी इज सिटिंग हियर. सो आई थिंक दैट वी शुड ट्रेन ऑफ अ स्टूडेंट. हम ये नहीं है कि आपको केवल क्लास में लिया वो पढ़ा के चले गए. अगर हम इस तरह से उनको स्टूडेंट को इनकलकेट करते हैं जिससे हमारे यंग स्टूडेंट हैं बहुत कुछ काम कर सकते हैं और इवन कर रहे हैं. जैसे हम लोग अगर एग्जाम्पल लेते हैं तो इंडियन स्टूडेंट का, आप कई सीईओ ऐसे हैं जो आप देख लीजिए कि आपका गूगल के सीईओ को देख लीजिए, माइक्रोसॉफ्ट के सीईओ के देख लीजिए, जो हमारे ही स्टूडेंट हैं जो इतना अच्छा परफॉर्म कर रहे हैं. तो हमारे स्टूडेंट बहुत अच्छा परफॉर्म कर सकते हैं. इन आउट ऑफ वे वी विल डेवलप द कल्चर ऑफ अ ऑर्गेनाइजेशन और इंस्टीट्यूट, हाउ द स्टूडेंट विल कम फॉरवर्ड इन ए क्यूरियोसिटी और सम ऑफ asking of some question, not we will penalize or something now. So I think that we should develop up this culture. इसमें कई हम लोगों का है, अगर स्टूडेंट हमारे पीएचडी में जब ज्वाइन करते हैं, कभी कभार हम लोगों ने देखा होगा प्रैक्टिकली जो हमारा ऑब्जर्वेशन है और हमारा एक्सपीरियंस है, स्टूडेंट को ऑब्जर्व करके बोल देते हैं कि एक रिव्यू पेपर लिखना है. आई थिंक दैट दिस इज ए रॉन्ग. जब तक उसको नॉलेज नहीं हो जाएगी तो रिव्यू पेपर कैसे लिख सकता है? तो मुझे लगता है कि पहले हमें ट्रेंड करना चाहिए और ट्रेंड करके इस तरह से उसको लेके आना चाहिए, तब रिव्यू पेपर लिखना चाहिए. तो हमारे जो यंग स्टूडेंट हैं उनको हमें ट्रेंड करने की सबसे पहले जरूरत है. जिस हिसाब से उनसे हम एक्सपेक्टेशन करते हैं कि बहुत अच्छा काम करेंगे, लेकिन साथ में हमें टारगेट भी फिक्स रखना चाहिए। अगर आपका टारगेट ये है कि आपको इतना काम करना है, आपका रिव्यू मीटिंग भी वीकली होना चाहिए और उनका डिस्कशन होना चाहिए, व्हाट यू हैव डन इन दिस वीक, व्हाट यू हैव टारगेटिंग इन ए नेक्स्ट वीक. I think we will inculcate of this culture in every organization, then we will contribute for our country. So in a small things we can contribute as a Viksit Bharat by organizing of this conference, and we inculcate of a exchange of a idea and some of a research. So I think that we should develop of this culture in a academic institution or especially in a national important institutions, so every student or every citizen of India, they can contribute to develop of a Viksit Bharat. हम लोग presently we will see that in a position of India is publish of a paper in a third position. So you will see the what is a research output. Around the world you will see the what India is contributing to publishing of a paper and develop of a technology. Even that in a patent you will see that in a current scenario, so lot of patent it comes from a India side. So resultly you have seen that in a currently in a last 5 year, so most of our institute is go in a good QS ranking. This is a result of our research culture as well as working in a different domain or different dimension. बट वी शुड डेवलप अप दिस कल्चर. एक हम एग्जाम्पल लेना चाहते हैं जो आपको कल्चर का डेवलपमेंट का डिफरेंस आपको क्रिएट दिखाई देगा. सिलेक्शन कमेटी में मैंने एक्सपर्ट बुलाए, एनआईटी के एक्सपर्ट और आईआईटी के. जब मैंने संपर्क किया तो उनको मेल किया, फोन किया. मेल करने के बाद जो हम लोग कहते हैं कि आईआईटी का इतना रेपुटेशन क्यों अच्छा है, उसको इंडिया में आउटसाइड ऑफ इंडिया इनकी रेपुटेशन क्यों है, दे हैव डेवलप देयर कल्चर. और कल्चर क्या है कि इंडिविजुअल कंट्रीब्यूट करने से ही आती है. जैसे उसका एक एग्जांपल है, जब हम एक्सपर्ट का अगर सेंट्रल यूनिवर्सिटी और एनआईटी के एक्सपर्ट से डिस्कस करते हैं और आईआईटी के उससे डिस्कस करते हैं, आप कम्युनिकेट कर रहे हैं, तो उसका मेल का रिप्लाई उसी दिन आ जाता है आईआईटी के एक्सपर्ट का, और एनआईटी और सेंट्रल यूनिवर्सिटी के एक्सपर्ट का मेल का रिप्लाई आप एक बार फोन करेंगे तब आता है. सो यू शुड चेंज योर कल्चर. माय पर्पज इज दैट वी शुड चेंज द कल्चर ऑफ इन ए इंस्टीट्यूट. इसमें कई ऐसी चीजें हैं कि मैं थोड़ा अपना पर्सनल एक्सपीरियंस आप लोगों के साथ में शेयर कर रहा हूं. वन ऑफ एक्सपर्ट इन ए यूपीएससी, just they observe of a whole things, how you have contribute of a in this paper or a innovation or what you have contribute. They have gone through of all the detail. Accordingly they have decided the result. But some of the expert is there, they only focus for a teaching. मैंने खुद ऑब्जर्व किया है कि कई एक्सपर्ट ऐसे हैं, स्टूडेंट का बहुत अच्छा काम है लेकिन बट ही इज नॉट कम्युनिकेटेड वेरी वेल. और आपका क्या है कि ये बहुत अच्छा है कि हो सकता है इस इंस्टीट्यूट में और लोगों का नहीं है इसलिए उसको सेलेक्ट नहीं करते. सो यू शुड सी द ऑब्जर्वेशन ऑफ अ डिफरेंट एक्सपर्ट. सो वी विल मेक अ एनवायरमेंट इन ए सच ए वे, बी रिसर्च कल्चर एज वेल एज अ answering and curiosity of a student, we will try to address it. So we will change the total culture. So I think that this type of a conference and this type of a conference is organizing and giving a platform to discuss lot of things whatever is going on a different. So even that we have seen that the name of this conference IC, EC and SP. So in a whole integration of electronics, instrumentation and control, electronics and communication and signal processing. So you have seen that in a different domain how we will contribute. So you will see that in this conference, I think that you will enjoy in a 3-day, and we wish all the best for a successful of this conference. So all the best from my side. Thank you.
Thank you so much, sir. In the grand scheme of things, the direction and support provided by the leadership of our institute plays a pivotal role. It is with immense pleasure that I invite the Conference General Chair, Professor Dr. Ajay Kumar Sharma, Director, NIT Delhi, to address the gathering. With his invaluable guidance and support, NIT Delhi has secured an excellent 51st rank in the engineering category of NIRF ranking 2023. Please, sir.
Good morning to all of you. Chief guest of the day, Dr. Shiv Kumar Sharma, the organizing secretary of Vigyan Bharati, Dr. B.K. Kanojia, director of NIT Jalandhar, Dr. Shashi Dhiman, the vice chancellor of HP Technical University, Dr. Sudesh Kumar, the director of CSIR Palampur, Dr. Manoj, head of the department, Dr. Basu, Dr. Manisha Bharti, and Registrar of NIT Delhi, Dr. Jyotish Malhotra, and various experts from the other institutions, the various participants from the other organizations, my dear students. It's my proud privilege to be here, especially on the inaugural session of this international conference. So I would like to mention that this is the first conference which has been organized by the Department of Electronics and Communication Engineering. But this is not the first conference of NIT Delhi. It is now the 8th conference, international conference, which has been organized by NIT Delhi. At the outset, I would like to congratulate the head of the department and Dr. Manoj, because this was the brainchild of Dr. Manoj. He has initiated this initiative to organize this international conference. So during these 3 days, I think all the participants, they are going to be benefited by this conference, because all the researchers, they are going to present their findings, and you can exchange your ideas and you can interact with the experts. There are various keynote speakers. So specialized talks have been organized by the organizers. So I feel that all the students, the PhD scholars and the UG students as well as the MTech students, they are going to be benefited by this conference. I hope that various tracks has been organized, and as Dr. Manoj has mentioned, we have received the wonderful response in this conference, and more than 600 papers have been received, and out of which 240 papers have been accepted, and now 160 papers are going to be presented by the various presenters. So I feel that you all going to be benefited by this conference. So I wish that this is a successful conference, and I wish that your stay will be comfortable. So with these words, thank you very much. Jai Hind, Jai Bharat.
Thank you, sir, for those insightful words.
Now it's my privilege to invite our chief guest, Dr. Shiv Kumar Sharma, to impart his valuable insights and vision. His unwavering commitment to societal development has impacted various communities across the states of India. Please, sir.
आप सभी को सादर नमस्कार। आपकी बॉडी लैंग्वेज ऐसी बता रही है कि काफ़ी कुछ लंबे भाषण सुन करके आप कुछ है। इस कॉन्फ्रेंस में उपस्थित अपने इस एनआईटी के डायरेक्टर प्रोफेसर अजय शर्मा जी, प्रोफेसर शशि कुमार धीमान जी, प्रोफेसर सुरेश कुमार यादव जी, प्रोफेसर कनौजिया जी, अन्य सभी विशिष्ट अतिथिगण तथा उपस्थित सभी छात्र भाइयों बहनों, स्पीकर्स की बात को सुनकर के मेरे मन में एक प्रश्न खड़ा हो रहा था। द एकेडमिक पॉइंट ऑफ व्यू बहुत सी बातें अपने सामने आई हैं। इस कॉन्फ्रेंस का हेतु क्या है, व्हाट इज द बेसिक पर्पज ऑफ दिस कॉन्फ्रेंस, एंड इन नेक्स्ट थ्री डेज कौन से टॉपिक पर वी विल डिस्कस अबाउट दैट एंड द रिसर्च पेपर्स आल्सो। इन सभी बातों के बारे में अपने सामने बहुत से विचार आए हैं। मैं उसके बारे में कुछ नहीं कहने वाला। मैं उसका एक दूसरा पॉइंट ऑफ व्यू से सोच रहा था। इस कॉन्फ्रेंस के जो टाइटल है उसमें कम्युनिकेशन एंड सिग्नल प्रोसेसिंग ऐसे शब्द का प्रयोग किया है। ये जो कम्युनिकेट करना है तो इसका जो साइकोलॉजिकल मेथड है इसके बारे में, बिकॉज मैं एक ऑर्गेनाइजेशन में काम करता हूं नियर अबाउट 40 ईयर्स, 40 साल से अपनी फॉर्मल एजुकेशन कंप्लीट करने के बाद एक संगठन शैली से एक ऑर्गेनाइजेशनल सिस्टम के आधार पर समाज में भिन्न भिन्न प्रकार के अलग अलग तरह के लोगों से मिलने का, बात करने का, अपने आइडियाज कम्युनिकेट करने का, दूसरों के आइडियाज सुनने का, इस प्रकार के विषयों को लेकर के मैं नियर अबाउट 40 ईयर्स, 40 साल से काम कर रहा हूं। दो साइडेड होते हैं। एक कम्युनिकेटर रहता है जो अपनी बात कहना चाहता है, दूसरा लिसनर रहता है जो सुनना चाहता है। तो इन दोनों के बीच में कुछ चीजें कॉमन होती हैं। मेरे मन में कुछ आइडियाज आ रहे हैं एंड आई वांट टू शेयर टू ऑल ऑफ यू। तो उसको शेयर करने से पहले जो थॉट्स रहते हैं, जो आइडियाज रहते हैं, जो विचार रहते हैं, हमारा ब्रेन का जो न्यूरो सिस्टम है, मैं केमिस्ट्री फील्ड का विद्यार्थी हूं तो थोड़ा उसके दृष्टि से ज्यादा विचार करता हूं। तो सबसे पहले हमारे जो हेमस्फीयर पार्ट है, जो ब्रेन सिस्टम है, उन आइडियाज को एक सिस्टमेटिक सीक्वेंस में लेकर के आता है। व्हाट एक्चुअली आई वांट टू से टू यू, वो क्या है, व्हाट इज दैट आइडिया, व्हाट इज द बेसिक सेंस ऑफ दैट आइडिया एंड व्हाट इज द पर्पज ऑफ बिहाइंड दैट आइडिया। तो उस कम्युनिकेशन के पीछे का जो सेंस है, जो इलेक्ट्रॉन्स काम करते हैं और जिसके आधार पर वो जो हेमस्फीयर है वो उसको किसी एक लैंग्वेज में कन्वर्ट करता है। मैं आपसे हिंदी में बात कर रहा हूं, दैट मीन्स मेरे ब्रेन के न्यूरॉन्स उस लैंग्वेज को हमारे उस आइडिया के साथ में कोरिलेट कर रहे हैं। एक बहुत अच्छे मोटिवेटर हुए हैं, संघ के एक बड़े अधिकारी हुए हैं, मानव दत्तोपंत ठेंगड़ी जी। वो एक बात कहते थे कि स्पीकर ने क्या कहा दैट इज नॉट इंपॉर्टेंट, लिसनर ने क्या समझा दैट इज द बेसिक सेंस। आप सब सुन रहे हैं, आप सुनेंगे तो वही जो मैं बोल रहा हूं, लेकिन व्हाट इज द अंडरस्टैंडिंग बिहाइंड दैट आइडिया, वो जो उसके पीछे की समझ है, जो समझना चाहिए, व्हाट एक्चुअली आई वांट टू से टू यू, व्हाट एक्चुअली आई वांट टू कम्युनिकेट टू यू, वो जो बात है वो अगर समझ में आई तो फिर बात पूरी हो जाती है। अदरवाइज क्वेश्चंस पुट अप होते हैं, व्हाई दिस, व्हाई नॉट दैट। तो कम्युनिकेशन में, क्योंकि हम कम्युनिकेशन के स्किल के ऊपर या कम्युनिकेशन के विषय के ऊपर चर्चा कर रहे हैं, तो नेचुरली हमारे जो न्यूरॉन्स जब काम करते हैं, हमारे इलेक्ट्रॉन्स जब उसको एक सिस्टमेटिक सीक्वेंस में लेकर के आते हैं, तो उसके आधार पर बॉडी लैंग्वेज ये रिएक्ट करती है, आई कांटेक्ट रिएक्ट करता है, बॉडी लैंग्वेज रिएक्ट करती है, रिसेप्टिविटी हो रही है कि नहीं, अंडरस्टैंडिंग हो रही है कि नहीं, ये चीजें उसमें से फीडबैक मिलती है। तो हम जब किसी कम्युनिकेशन के आधार पर किसी विषय को किसी के साथ शेयर करते हैं, तो नेचुरली 7वें अध्याय में भगवान कृष्ण ने पूरी गीता को अगर आप विचार करिए तो क्या है, कम्युनिकेशन इन बिटवीन टू पर्सन्स। अर्जुन प्रश्न पूछ रहे हैं और कृष्ण उसके उत्तर दे रहे हैं। तो 7th चैप्टर में कृष्ण कहते हैं, वो चर्चा कर रहे हैं, प्रश्न कर रहे हैं, ज्ञान योग, भक्ति योग, कर्म योग एंड सो मेनी टाइप ऑफ आइडियाज आल्सो। तो उन प्रश्नों के उत्तर में 7th चैप्टर में कहते हैं, अधिष्ठानम तथा कर्ता कर्णम च पृथक विधम विविधाश्च पृथक चेष्टा दैवात्र पंचमम। कम्युनिकेशन के 5 स्किल्स की चर्चा करते हैं। What is the adhishthan? Adhishthan means the basic sense of understanding capacity, what I want to share with all of you. वो जो मूल है, वो जो प्राण है, वो अधिष्ठान है। गीता के बारे में सामान्य रूप से जो मैनेजमेंट वाले लोग हैं वो कहते हैं कि जो कुछ हम समाज में बताना चाहते हैं वो सभी चीजें गीता में किसी न किसी रूप में है। उसको आइडेंटिफाई करना, उसको अंडरस्टैंडिंग में लेकर के आना, उसको प्रेजेंटेशन पावर में लेकर के आना, उस ढंग से प्रेजेंट करने के लिए अपनी कैपेसिटी बिल्डिंग करना, ये एक अदर सेंस है। तो अधिष्ठान, अधिष्ठान यानी मैं जो कुछ आपको शेयर करना चाहता हूं उसकी क्लियरिटी, हम एज ए स्पीकर हमको कितनी क्लियरिटी है, दैट इज द अधिष्ठान ऑफ दैट सेंस। लेकिन केवल अधिष्ठान से तो काम नहीं बनेगा। जो स्पीकर और लिसनर के बीच में कम्युनिकेशन हो रहा है, उस कम्युनिकेशन के लिए जो अंडरस्टैंडिंग चाहिए, अगर सुनने वाले को समझने की इच्छा नहीं है तो कुछ भी कहिए कोई फायदा नहीं है, क्योंकि सुनने वाला वो माइंड सेट में नहीं है, वो पहले से ही मानता है कि हाँ ये ठीक है, इनका काम है कुछ कहना और हमारा काम है थोड़ी देर के लिए शांति से बैठ करके सुनना। अगर ये रिलेशनशिप है, दैट मीन्स नो सेंस ऑफ शेयरिंग द आइडियाज। तो केवल अधिष्ठान से काम नहीं बनता, यानी कहने वाले के मन में अंडरस्टैंडिंग हो जाए, केवल इससे काम नहीं बनता। सुनने के वाले मन में भी रिसेप्टिविटी है कि नहीं, उसके लिए एक सिचुएशन क्रिएट करते हैं। ये कॉन्फ्रेंस एक्चुअली में उस प्रकार की सिचुएशन क्रिएशन का माध्यम है। जो स्पीकर्स आएंगे समय समय पर अपने विचारों को हमारे सामने प्रस्तुत करेंगे, हम उनके साथ में कितने कोरिलेट हो रहे हैं, कितना अंडरस्टैंडिंग लेना चाहते हैं, हम उस अकॉर्डिंग टू दैट सिचुएशन व्हाट इज द बेसिक आइडियाज एंड व्हाट इज द साइकोलॉजिकल सेंस ऑफ आवर थिंकिंग, वो हमारी जो साइकोलॉजी है, हमारा जो मनोविज्ञान है, हमारी जो सुनने की और समझने की इच्छा शक्ति है, वो उस कम्युनिकेशन का प्राण तत्व है। तो दैट इज द सेकेंड पार्ट। कृष्ण कहते हैं कि केवल इतने से भी काम नहीं बनता, एक अनदर थर्ड पार्ट आल्सो, तीसरा एक और भाग है। वो है कि उस कम्युनिकेशन के बाद हमारी जो अंडरस्टैंडिंग बनती है उसमें क्वेश्चन पुटअप होते हैं, तरह तरह के सवाल खड़े होते हैं जो कॉन्सेप्ट को क्लियर करते हैं। केवल विषयों का प्रतिपादन करना मात्र उद्देश्य नहीं है, उस विषय के प्रतिपादन में से जो क्वेश्चंस आते हैं, जो नई नई प्रकार की क्यूरियोसिटी है, जिज्ञासा है, उसका समाधान होना चाहिए। तो क्या है, फिर वो कंटिन्यूटी बनती है, एक प्रोसेस बनता है, एक निरंतरता बनती है और उसकी एक्सेप्टिंग पावर बढ़ती है। ये तीसरा मेथड है, तीसरा जो विषय रहता है कॉन्फ्रेंस में, जब हम अलग अलग प्रकार के रिसर्च पेपर्स प्रस्तुत होते हैं, उस पर डिस्कस होता है, उस पर विभिन्न प्रकार के प्रश्न खड़े किए जाते हैं, तो उन प्रश्नों के समाधान के आधार पर जो तीसरा भाग कृष्ण ने कहा, उस आधार पर हमारी केवल अंडरस्टैंडिंग नहीं बनती, तो हम उसके साथ में कुछ करने के लिए इंप्लीमेंटेशन जो आधार है, उसके लिए हमारा माइंडसेट बनता है। केवल एक्सेप्टेबिलिटी नहीं होती, केवल स्वीकार कर लिया, हाँ आप अच्छा कह रहे हैं, ठीक कह रहे हैं, इतने से काम नहीं बनता। तो उसके लिए हम कुछ करने के लिए उद्यत होते हैं। इस तरह की कॉन्फ्रेंस में वो जो चौथा भाग है, जो तीसरा भाग है, ये इसमें इसके आधार पर काम करता है। कृष्ण कहते हैं कि ये भी सफिशिएंट नहीं है, एक चौथा भाग होता है जिसके आधार पर आगे की कंटिन्यूटी बनती है, निरंतरता बनती है, और लाइफ में उस कम्युनिकेशन की जो भी विषय हमने सुने हैं उसको कैसे इंप्लीमेंट करना, कैसे उसको स्किलिंग सेंस में लेकर के आना, वो सिस्टम उसके अंदर से डेवलप होता है। फिर उसके अंदर हम काम करना शुरू करते हैं, उसके अंदर तरह तरह के प्रश्न खड़े होते हैं, और प्रश्नों के समाधान के आधार पर हमारी जो एक्सेप्टेबिलिटी बनी है उस पर हम इंप्लीमेंट करते हैं, कार्य करते हैं, क्रियान्विति प्रारंभ होती है। पूरे 18 अध्याय सुनाने के बाद कम्युनिकेशन तो बढ़िया हो गया कृष्ण का और अर्जुन का, लेकिन अर्जुन ने लास्ट तक एक्सेप्ट नहीं किया कि मैं युद्ध करूंगा। तो कृष्ण को पूछना पड़ा कि भैया इतना कम्युनिकेशन हो गया, इतनी बातें मैंने आपके सभी प्रकार के प्रश्नों का समाधान कर दिया, व्हाट विल यू डू नाउ, करोगे क्या? तो 18वें अध्याय में अर्जुन का जो उस पूरी कम्युनिकेशन स्किल के आधार पर जो उन्होंने बात कही है, नष्टो मोहा स्मृतिर्लब्धा, what actually you want to say to me, I understand, I accept and I will do as you will say, कृष्य वचनम तव, जो आप कहेंगे वो मैं करूंगा। आप युद्ध करने के लिए कहेंगे मैं युद्ध करूंगा। ये जो 5वां भाग है कि उसकी कंटिन्यूटी बनती है, कैरी ऑन होता है, इंप्लीमेंट होता है वो कम्युनिकेशन। वो जो इंप्लीमेंटेशन वाला जो पार्ट है वो लाइफ को चेंज करता है। हम जब टेक्नोलॉजी पार्ट में काम करने वाले लोग हैं, जब हम अपने रिसर्च के आधार पर समाज में अपने विषय को लेकर के जाते हैं तो वो विषय इंप्लीमेंट होता है, यानी जीवन की उस दृष्टि को निर्माण करता है, करिष्ये वचनम तव। लेकिन कंडीशन लगाते हैं, ये जो कंडीशन है, शर्त है कि इस निरंतरता को बनाए रखने के लिए आपको हर पल मेरे साथ में रहना पड़ेगा। भिन्न भिन्न प्रकार के प्रश्नों के समाधान में आपको हमारे साथ रहना पड़ेगा। और पूरी गीता के लास्ट में जो कहा है कि अहम त्वाम सर्व पापेभ्यो मोक्षयिष्यामि मा शुचि, यानी वो एक्सेप्ट करते हैं कृष्ण। जैसे हम प्रोफेसर्स के और स्टूडेंट्स के बीच में, मैं अपने आप को एक स्टूडेंट ही मानता हूं, क्योंकि मैं कोई टीचिंग मेथड में काम नहीं करता, टीचिंग प्रोसेस का व्यक्ति नहीं हूं, हाँ स्टूडेंट्स जरूर हूं। तो हम लोग जब टीचर्स के साथ में डिस्कस करते हैं, वो हमारी प्रॉब्लम को सॉल्यूशन देते हैं, रिसर्चर्स के आधार पर नए नए प्रकार की प्रॉब्लम क्रिएट होती हैं, उसको रिमूव करते हैं। ये जो कंटिन्यूटी चलती है, जो निरंतरता चलती है, इस निरंतरता के कम्युनिकेशन में हमारी एक इच्छा होती है, हमारी एक्सपेक्ट होता है कि हमारा प्रोफेसर, हमारे जो चिंतक हैं, वो हमारे मार्गदर्शक हैं, वो नष्टो मोहा स्मृतिर्लब्धा के आधार पर हमारे साथ चलेंगे। यानी जब भी कोई प्रॉब्लम क्रिएट होती है उस समय हमारा उस मार्गदर्शन करने का काम, हमारी दिशा प्रबोधन करने का काम। और गीता के अंतिम श्लोक में, मैं क्योंकि साइकोलॉजिकल बात की चर्चा कर रहा था, एकेडमिक पार्ट तो हमारे सीनियर जो स्पीकर्स हैं उन्होंने कहा ही है और सब आगे 3 दिन के उसमें करने वाले हैं। तो गीता के जो राइटर हैं भगवान वेद व्यास जी, वो अंत में एक श्लोक के अंदर पूरी गीता का सार बता देते हैं कि जब 2 इस प्रकार के लोग रहते हैं और इस प्रकार के आइडियाज को कम्युनिकेट करते हैं, प्रश्न खड़े करते हैं, उनका समाधान होता है, तो उसमें कंडीशनल क्या है, शर्तें क्या है, 2 शर्तें हैं, श्रोता और वक्ता के बीच की 2 शर्त का बात करते हैं। तो वो कहते हैं कि अगर ये पूरी परिस्थिति निर्माण करनी है और कम्युनिकेशन के आधार पर विषयों का प्रतिपादन करना है, वो चाहे जिस भी प्रकार की टेक्नोलॉजी हो, उसमें वो जो बेसिक सेंस दोनों काम करती हैं, उसमें अर्जुन जैसा व्यक्ति होना, यत्र पार्थो धनुर्धर, पार्थ जैसा धनुर्धर, यानी वैसा जिज्ञासु होना चाहिए जिसके मन में प्रश्न खड़े होते हैं, लेकिन उसका समाधान देने की कैपेसिटी रखने वाला कृष्ण होना चाहिए। ये दोनों चीजें जब रहती हैं तब तत्र श्री विजयो भूत ध्रुव नीतिर्मतिर्मम, तब श्री और विजय, यानी जो चीज हम प्राप्त करना चाहते हैं, इस कॉन्फ्रेंस का जो बेसिक आइडिया है जिसके आधार पर हम उस चीज को आफ्टर ऑल अचीव क्या है, अचीव क्या करना चाहते हैं, वो अचीवमेंट्स पूरी होती है। यत्र पार्थो धनुर्धर तत्र श्री विजयो भूत ध्रुव नीतिर्मतिर्मम। ये जो साइकोलॉजिकल पार्ट ऑफ कॉन्फ्रेंस रहता है, मुझे लगता है कि हम सभी विद्यार्थी, हम सभी जो हमारे सीनियर प्रोफेसर्स हैं उस दृष्टि को रख करके इस कॉन्फ्रेंस के अंदर इन्वॉल्व होंगे तो नेचुरली इसका जो बेसिक पर्पज है वो हमको प्राप्त होगा। माँ भारती हमको ऐसा आशीर्वाद दे। ऐसी बात पूर्ण करते हुए मैं बात पूर्ण करता हूँ। धन्यवाद।
Thank you, sir, for those enlightening thoughts.
Now it's time to announce the release of the conference proceedings. I request the dignitaries to kindly unveil the significant compilation of scholarly work. I also request the audience to please give a huge round of applause. In addition to the release of the conference proceedings, we are absolutely delighted to announce the signing and formal presentation of a significant Memorandum of Understanding, MOU, between our institute and two esteemed partner institutions. This MOU signifies the commencement of collaborative efforts aimed at advancing research, fostering innovation, and strengthening academic partnerships. First, we present the MOU between NIT Delhi and CSIR, Institute of Himalayan Bioresource Technology, Palampur, highlighting our commitment to joint research and academic excellence. I request the representatives from CSIR IHBT to come forward and take part in this momentous ceremony. Following this, we introduce the MOU between NIT Delhi and Himachal Pradesh Technical University, which will enhance our shared goals of educational development and technological advancement.
As we near the end of our inaugural session, I would like to express our sincere gratitude to everyone who made this event possible. For the concluding remarks and vote of thanks, I invite Dr. Manisha Bharti, Conference Organizing Secretary, to the stage. Please, ma'am.
Thank you, Beta. Namaskar and a very good afternoon to all present here in the auditorium. Thank you and sense of gratitude is such a prayer that cannot be seen or touched, but it is felt by heart. It is indeed an honor to be a part of this wonderful event. At the end of the inaugural session, it's my privilege to propose a vote of thanks to all our esteemed guests, dignitaries, participants outside NIT Delhi and family of NIT Delhi too, who have joined us for the event today. First and foremost, thanks to Almighty for His blessings. On behalf of NIT Delhi fraternity, I sincerely thank our chief guest, Dr. Shiv Kumar Sharma ji, National Organizing Secretary, Vigyan Bharti, for taking time from his busy schedule and gracing the occasion with his warm presence. It was great that you joined our event and bestowed us for being chief guest. It is indeed a great honor for our institute to have the presence of Dr. Sudesh Kumar Yadav, Director, CSIR, IHBT, Palampur, Professor Shashi Dhimanji, Vice Chancellor, HPTU, Himachal Pradesh, Professor B.K. Kanojia, Director, NIT Jalandhar, Professor Manju Bala, in absentia, Director, cum Principal, Khalsa College of Engineering and Technology, Professor Subrata Mukhopadhyay, in absentia, from IEEE Delhi section. All are known for their great contributions to their respective research fields. I thank all the distinguished guests for gracing the occasion with your wonderful presence. Words are not enough to express gratitude and thanks to our Honorable Director Sir, Professor Dr. Ajay Kumar Sharma, a prudent mentor, diligent guide for his constant guidance and motivation to shape this conference. I take this occurrence to thank our keynote speaker, Professor Sudev Das Gupta ji from IIT Roorkee and Professor Go En Chang from National Chung Chang University, Taiwan, for accepting the invitation and joining us for the occasion. Thank you, sir. The Institute gratefully appreciates the presence of Professor Jasdeep Kaur Dhanua, Madam, Vice Chair, IEEE Delhi Section. Thank you, ma'am, for your gracious presence on this occasion. I'm thankful to Registrar Sir, Administrative Department of NIT Delhi for their support and help to organize this conference. No one can whistle a symphony. It takes a whole orchestra to play it. It is a well-known fact that organization of such events are the result of hardcore and sincere efforts made by all. We have been fortunate enough to be backed by a team of very motivated and dedicated faculty, non-faculty, and staff members of our institute. I especially thank everyone from the Electronics and Communication Engineering Department for the involvement they have shown and the willingness they have expressed to take on the completion of tasks beyond their comfort zones. We have also been quite fortunate to have worked with sincere PhD research scholars and staff of our department who made themselves available whenever required and helped make this event possible. I'm thankful to our financial supporters and Tupel Technologies, Khalsa College of Engineering and Technology, Atanix Technologies, Silicom Electronics Private Limited, ARK Info Solutions, Trinity Microsystems Private Limited for their financial support. We are very much grateful to our technical supporters, IEEE Delhi Section, IEEE Photonics Society, IEEE Circuits and Systems Society for your help and support. The support rendered by you not only adds a special touch to our conference experience, but also underscores your commitment to fostering professional development. I would like to thank the people who worked behind the scene to make this event happen. My special thanks to HCC Computer Center team for all the technical arrangement, management teams, all the committee in charges, and the housekeeping staff of the institute. Learning is always a good opportunity to feel our minds as it helps us grow. Through such informative events, we get a chance to boost our knowledge, to dive into a field of subject that might be very much unfamiliar to all of us. So I would like to take my time in thanking our dear participants and attendees, as well as the audience who took their time out to be a part of this event. If time is money, then today I must say that you have spent millions for us. Thank you to all the members of NIT Delhi, including deans, heads, faculty, non-faculty, and staff, as well as the members and dignitaries from outside NIT Delhi for making this event successful. I pray that all the gathered here will have an enriching and memorable experience during these 3 days. Thank you. With these words, thank you very much once again, and God bless you all. Thank you.
Thank you so much, ma'am. To conclude our inaugural session, let us all rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 जय
As we close this session, we invite everyone for a group photograph to capture this memorable occasion. Please join us on the stage for the photograph.
We will meet again for the first keynote talk by Professor Sudhir Das Gupta from IIT Roorkee shortly after IIT at 12:45.
Please students, please join for the photographs. All from the back side, please join for the photographs.
The audience is also requested to kindly join in for the photograph. everybody. It is my distinct honor to welcome you all to the first keynote session of ICECSP 2024. Today, we stand at the crossroads of knowledge, innovation, and collaboration, each a vital component in the advancement of our field. This conference not only celebrates our collective achievements, but also serves as a platform to set new standards of excellence and to inspire future innovations. To commence our event, it is a privilege to introduce our distinguished keynote speaker, Professor Sudebdas Gupta from Department of Electronics and Communication Engineering at IIT Roorkee.
Professor Gupta's groundbreaking research and profound expertise have significantly contributed to the evolution of electronics and communication technologies. Now, I request Dr. Manisha Bharti to kindly felicitate Professor Sudebdas Gupta. Audience, you can have a seat in front of the rows. The seats are empty. The session chair for the same would be Dr. Sneha Kabra. I invite Dr. Manisha Bharti to kindly welcome her and greet her. Kindly give a huge round of applause.
I'd now like to invite Dr. Manisha Bharti to kindly introduce our keynote speaker.
Good afternoon, everyone. Welcome back to the first keynote talk of today. It's my pleasure to introduce first the session chair of this session, Dr. Sneha Kabra. She is a distinguished expert in the field of electronics, having secured her academic credentials, bachelor's degree and PhD in electronics from the esteemed University of Delhi in 2001, 2003 and 2008 respectively. Her academic journey commences as a lecturer in ECE department at Acharya Narendra Dev College, University of Delhi. As a senior member of IEEE and fellow of IETE, Dr. Kabra has undertaken pivotal leadership roles including Secretary of the IEEE Electronic Device Society, Delhi Chapter 2017 to 19, Treasurer of IEEE Delhi Section 2020 to 2022, and Secretary of Women in Engineering Affinity Group IEEE Delhi Section 2019-2023 to 24. Dr. Kabra's research is centered on the modeling, simulation and characterization of advanced deep submicron semiconductor devices applicable to biosensing, gas sensing, RF and digital circuitry. With a keen focus on the academic mentorship, Dr. Kabra is presently guiding 2 research scholars and has successfully supervised completion of 3 PhD theses and 2 MTech dissertations. She was bestowed the Meritorious Teacher Award by the Government of NCT of Delhi in March 2022 under the Award for College Lecturers Initiative. We welcome you, ma'am, here on behalf of NIT Delhi. Now, it's my proud privilege to introduce the keynote speaker of the day, Professor Sudebdas Gupta. He is presently working as professor in the Department of ECE at IIT Roorkee. He received his PhD degree in ECE from IIT Banaras Hindu University, Varanasi in 2000. He was awarded with Erasmus Mundus Fellowship of European Union in the year 2010 to work in the area of RDF at Politecnico di Torino, Italy. He is a recipient of prestigious ICECSP to work in the area of SRAM testing at University of Wisconsin at Madison, USA in the year 2011-12. He was also awarded with DAD Fellowship to work on analog design using reconfigurable logic at TU Dresden, Germany. His area of interest are nanoelectronics, nanoscale, MOSFET modeling and simulation, design and development of low-power novel devices, FinFET-based memory design, emerging devices in analog design, and design and development of reconfigurable logic. He has guided 18 PhD scholars. Currently, he is supervising around 6 candidates leading to their PhD degree. With this brief introduction, I invite you, sir, on the stage to start with the keynote talk. Thank you so much.
Slide changer कैसे हो? Sure. Okay, good afternoon all of you, and since it's we are already running late and I know we are already breaking into the lunch hour, so I will keep it the keynote, this first keynote, to be short and sweet for all of you. Typically I will take about 45 minutes of your time and try to give you an insight into the reliability challenges of gate-all-around nanosheets and Forksheet FETs and its circuit implication. So this is sort of work has been under the collaboration with Global Foundries, Intel and Samsung. Samsung Korea, Intel Bangalore and Intel San Jose, and Global Foundry Dresden and Global Foundry Bangalore. So that's our group. I am also supported by my colleagues at Roorkee, my postdoctoral people, and that's the reason I thought of discussing all these things with you. So what you see in front of you is our main administrative block, which was built in 1857-58 when the first resistance movement started in India. So this is a heritage site which we have, and this is known as James Thomson's building, and it is about more than 175 years old building. So let me give you a brief insight about what we will be doing this next half an hour, 45 minutes. So I will give you an evolution of nanosheets and Forksheet FETs. I'm assuming that all of you young students, most of you, I can see your faces, must be knowing what's a FET device, right? You all know what's a BJT, you know what's a MOSFET, how a MOSFET works, how a BJT works. With this presumption, this talk is being delivered. Then I will be coming to the problems and challenges in nanosheet FETs. Very, very important phenomena which is happening nowadays in nanosheet FETs is basically self-heating. We will look into the variability and reliability aspects of nanosheet FETs, and then I will just introduce to you Forksheet. Forksheet I might not be able to go in details because it requires a prior understanding, and then maybe give you a conclusion and further scope. A very important, not a diagram, but sort of a report which is coming from IEDM 23. So this is IEDM is a premier conferences and devices, and if we look carefully, if we look at this graph here, on the x-axis you have the mass production, on the y-axis you have the scale of production units which is there. So you see around 2030 when you will have these A10, A14 nodes being available, you will be having more than 1 trillion transistors per unit area of the chip. Which means that let's take this as your chip area. You will have 1 centimeter by 1 centimeter will have 1 trillion active devices with interconnects and passive devices with IO pads, everything built within it. So you see the great challenge which comes there is you need to shorten your device, reduce the length of your device,
and then also ensure that the power dissipation of individual devices are as small as possible. Right? For example, in this room, if so many people are sitting, if you increase the number of people, obviously the heat dissipation will increase and there will be discomfort here, right? Same thing happens on a silicon wafer. So that's the major challenge which people are facing, how to integrate and keep the power within the defined limits. Why do you do it? Because you don't want the functionality to be sacrificed, and that's the reason you have more than 1 trillion transistors are required. Look at Ultra Spark 4, right? This is a Spark family processor, and it has got 295 million already transistors inbuilt in it. Currently, you have CPU speeds of the order of 20 to 25 gigahertz, clock speeds of the order of 4 to 5 gigahertz, and these CPU speeds currently AMD has reported currently on their chipset a speed of on clock chip of approximately 25 gigahertz, right? So you can see the speed is increasing. You need to bring all the electrons or the devices, active devices, very close to each other, and there comes the problem of reliability and power dissipation. A brief idea where we are moving forward, looking forward, because this is for the young students is very, very important, because when you will be graduating, you know where you will be hitting, be it in industry when you do a placement, or be it if you want to go for research. Most of you will be graduating around 27, 24, 25 region, right? That is the time when your FinFET devices will be on the go. We expect current technology trends tells me that FinFET and FDSOI will be almost if not vanishing, they will be slightly fading away into the whole region. And what we will be looking into is basically vertical GAA FET and lateral GAA FET. The names looks very complicated, really very simple, conceptually very simple. This vertical GAA FET was, to the best of my knowledge, 2022 Samsung was the first person or the first organization which looked into vertical GAA FETs. So rather than moving like this, you start moving like this. You start to drop pillars, right? Now what conventionally people have been doing in VLSI domain is, if you have a silicon wafer here, you try to etch away your active devices in this domain, right? And then you make your interconnect follow a planar line like this. Now what has happened is, take my silicon chip here, you will do what? You will do vertical like this. You getting my point? Just like you do it when you're, for example, Delhi or Bombay has got less space, right? So where will the building go? The building goes like this. Exactly the same thing is happening in VLSI domain. That's where you will see a monolithic 3D integration and vertical GAA FET coming up in a big way. Easier said than done. I'm talking in front of you, it's very easy. You come to a fabricator, he will just throw you out of the fab lab, because growing a 3D vertical FET is a very, very difficult task. Structurally difficult, reliability wise also difficult, right? Because please understand, while doing all these things, I cannot compromise on the on current. I cannot compromise on the leakage current. I cannot compromise on the latency and power. These three things as well as area. You get the point? Now, the rule of thumb in VLSI, or those who are working in devices, is that if you are able to surround the gate properly in all the directions, then you have a better control. Makes sense also. You don't have to be an engineer to understand this, right? If in your house your father, mother, sister, brother is surrounding you and giving you inputs of information, you will be very much influenced by them. Whereas in your hostel, if you're staying alone in your room, you won't be influenced by too many people. You will have your own thought process, you will work. Exactly the same works here. When you have a GAA device surrounded by all sides, it's a better control. You have better control on the current. And these are all ITRs. I will recommend all young people to please go through this document. International Technology Roadmap for Semiconductors, which is a biannual process happens, and you can go through it and have a look at low year predictions and higher predictions. So I have given you an idea where we are heading, right? So let me do the first thing to you. I don't know, have you heard of FinFET, anybody? Yes, sir. Have you heard, right? MOSFET everybody has heard. Yes, sir. What is a MOSFET? MOSFET is what? You have a channel and you have a source, drain, gate. Gate will control the inversion layer. If your source is grounded, you apply a drain voltage, the current will flow, and that is the basic concept. As a current source, I can use it as a switch. What I do in the FinFET is conceptually exactly the same. This is source, that side is drain, and this green color is my gate, right? But you see, now my gate is surrounding the channel in 1, 2, and 3 directions, which means that there are effectively 1, 2, 3 fingers available to me. So the current will be 3 times of a single device. So using this technology, I was able to increase the on current by 3 times. You get the point? Any idea what will be the problem here? The problem is you are moving from a planar device to a quasi-planar device, which means that MOSFET was like this. A FinFET will be something like this. Something like this. So you have to grow laterally also. Reliability becomes a big issue here. And that's the reason this is there. Anybody from your devices 101, current is proportional to? In a FET device? Current is proportional to? W by L, aspect ratio, remember? Width of the transistor divided by length of the transistor. You see what you have done here effectively. This is my length of the transistor. This is my effective width. This, I can touch the screen, no? I should not touch it. Thanks. So, I will not touch, don't worry. So, I don't want it also, thank you. So, this is one width, this is another one, this is the third one. So, total width kitna ho gaya? 2 times the height plus this thickness. You get the point? You just have to raise this height, thoda sa upar badhaiye, you get almost double the change in W, double the on current. So that's the advantage. So this was FinFET. FinFET is still used. Intel uses FinFET in their processor nowadays very well, in a very deep manner. All digital PlayStations, Play Store used FinFETs for that purpose. Then came Nanosheet FETs. This is still under sort of research stage. Samsung has actually already implemented it in their memory logic, but for digital logic, this still is under state. See the picture, you will understand, those who understand devices. This is gate. Now the gate is surrounding the channel in all the 4 directions, and there are 1, 2, 3, 4, 5, 6. So there are, this is N-type, P-type, so there are 1, 2, 3. There are 3 channels being formed, and as you make the gate length larger and larger, you automatically have a larger amount of current, but straightforward. The third thing is a Forksheet. This is dicey. Let me all give you a pitfall here. Forksheets have still not taken up as much as it should be. This was first reported by IMEC Belgium sometimes in during the COVID era. I remember 2021 was the first paper from IMEC Belgium which reported a Forksheet FET. Very simple, very straightforward. You within the same active area as a FinFET, I will be able to have both N channel and P channel. So I can actually theoretically have a CMOS on the same area with same performance as an active device silicon. You getting the advantage? So you are basically able to in one go improve the current density by twice at least. That is the advantage of this one. Don't worry what is shown here and all those things. This is just a schematic diagram, easier said than done. This is the gate again. These are the 3 PMOS channels. These are the 3 NMOS channels. So what are the challenges which we have reduced? We were able to have much better subthreshold slewings for Forksheets. Your DIBL was much lower, and your leakage currents was very much small because of this dielectric wall. And my ion by IOF ratios were much better. We have already talked about this. I will just take one small work and then we'll move forward. See, in a FinFET, if you want to find out the current, it will be 3 times the on current of a single channel. So if a single channel carries 1 ampere, 1 microamp, 1 milliampere current, and if there are 3 channels, there will be 3 milliamp, very straightforward. But if a user comes to you and asks you that no, I don't want a 3 milliampere current, I want 2.5 milliamp current. you will not be able to deliver a 2.5 milliamp. This is known as quantization problem in FinFET. A major problem of FinFET or problem area is quantization. You can't, once fabricated and once you have defined the on current of a single fin or a single, this is the fin, this is the channel, this is the fin. Once you have defined for a single channel the current, you can only go in integer value of that only. You cannot have a non-integral value. Major issue which comes into picture here. Though I have not written here, but that's a major picture which you see, and therefore the problem of FinFET is always known to me. Let me come to nanosheet FETs. This was first done by Samsung way back in 2003. Samsung lab, I think in KAIST we have one, and we have in Seoul one, which works on memory design. Samsung is very famous for their memory architecture. So the problem came from the memory people, that they wanted to increase the memory bandwidth, which means that within the same silicon area, can I have a larger memory, right? So they came up with this device. What is happening is, in this case, is this is also referred to as, at that point of time it was referred to as a vertically stacked multi-bridge channel metal oxide semiconductor field effect transistor, also referred to as MBC FET. This was done way back in 2003, 2005, that was the time, right? So what they did was very simple and straightforward. I have a substrate here, I have a gate here, there is a source this side, drain that side, I have a channel. The gate is surrounding in all the 4 directions, please understand. This is the whole area, and then I have an STI here and STI. What is an STI, by the way, anybody? What is an STI? No, I'll help you out. This is known as shallow trench isolation. What you will do, when you grow a silicon, or when you do a silicon, you will take a silicon like this, you will grow an active device like this. Say you want to design a CMOS. You will have an NMOS, you will have a PMOS, and they will be very close to, if you are not using a twin tub process, you will grow one NMOS here, one PMOS here. Right? Agreed? There will be what? Correct. There will be a latch up, there will be a shorting between the two. You don't want that to happen, because these two are active devices. What you will do? You will grow a layer of dielectric between the two. Once you do that, you don't allow the current to flow from N to P and P to N. There is no shorting. That is, in a sense, in a very layman language, sort of is the STI. So I isolate this device from the nearby device. Correct? This is shallow trench isolation. And then what I do, I have a channel here. Look at this as channel. I grow an oxide layer around the channel, right? And then I grow a metal layer. So I have still a MOS structure available to me, but now my MOS structure is such that the metal is surrounding the whole of the channel. Unlike in a bulk MOSFET. Bulk MOSFET, it is only surrounding in one direction. In this case, it's surrounding in all the 4 directions, right? And the controllability is much better, therefore, in this case. So that's the reason we call this as a much better way of looking at it. Later on, yes, I wanted to show you this stem. This was, I think, reported, though it is coming from this reference source. Again, to the young people here, because this keynote is just not about technical knowledge, you should know how to do your presentation skills. When you present something which is not yours, please try to put a proper reference to those things, right? Then you are not you are free of copyright violations or plagiarism charges. So typically, whenever you take something from somewhere, put up a reference. No harm is done, right? And you are safe as well. Anyway, don't worry about it. Coming back to the topic, this is a TEM image of a nanosheet FET. You see, these are the sheets which I am talking about, right? And you see the problem. You see the very first problem you see. Growing a sheet of a dimension of about 3 to 4 nanometers or 5 nanometers, and realizing that the shape can change because of problems in the lithographic steps is a big challenge. So you wanted to grow a sheet like this, a square sheet. You ended up having a elliptical sheet. You tell me why this is so important? Anybody can help me? I wanted to grow like this sheet, nanosheet. Let me help you out. Take this, right? So this is it. I'm growing like a sheet like this, right? You wanted to grow like this, right? You ended up having a circular edge here. Can you tell me what is the problem then? Anybody? Intuitively? Huh? Fringing field effect. Anybody can help me out? Yes, Baljit, agree with you. So what is that? What will happen? Okay, let me do one thing. Let me make it. If I make the edges like this, the electric field will be directed inside like this. Do you agree? And therefore there will be a problem of fringing field. I'm sorry. So I'm extremely sorry. Okay, so there will be a problem of fringing field. What does it mean? The electric field is directed inwards and is pointing to a single point. Got the idea? दिक्कत क्या होगा उससे? Electromigration, heating effect. For example, agar you are all sitting in this on this auditorium, right? And I am applying equal force to all the 3 columns. You will be all able to share it. But then after some time I only put the highest force on this column, I forget about these 2. All of you will be shifting backwards, right? Same thing happens in a nanosheet effects. That if you make it rounded here, because of the fringing field, you will have large amount of stress generated here. Because of which there will be electromigration. The atoms of the metal will start itself moving away from its place. Reliability comes under problem. So it's very, very important that whenever you decide to, especially people with devices background or devices, you should always keep in back of your mind a good knowledge of fabrication will also help you to make it easier growth. So this is I wanted to just show it to you, and this is one important challenge which I wanted to point out, that the nanosheet FETs typically have a gauge spacer which is very difficult to draw. Something like this, that you have source here, you have drain here, and you have nanosheets here, and you want to draw a dielectric spacer here. Very, very difficult to draw using standard oxidation techniques, because you have already drawn the metal layer, or you have already drawn the epi layer, and therefore drawing the oxidized layer is a relatively difficult task. This is the work which we have done at IIT Roorkee, and this device was given to us by GF Bangalore, and that's the reason I took their name during the starting of the slide. And they have this device with them, by the way, so it's not very ingenious. Nothing very extraordinary, difficult also. What we did is, whenever you do a device, you first do a calibration. And therefore, what we did, we took this, we did an experimental IDVD curve or IDVG curve, and then we plotted using TCAD and tried to match them together on the same profile. Why do we do that? So that we are sure that the device which is given to us and the TCAD which we are trying to match it with has the same physics inbuilt within themselves. You getting my point? I will give an example, short example, which will possibly make you clear. Remember bulk MOSFET? Have you heard of? No, I don't. Those who are working, they will. Gradual channel approximation? No. How do you solve basic MOS device? You start with Poisson equation. Electric field with charge. Once you know the potential profile, you know the electric field. Once you know the electric field, you know the charge. Once you know the charge, you integrate the charge from source to drain. Total charge, then total charge flowing per unit area, per unit time is the current. That's what is the traditional electrostatic, electrodynamic sort of movement. You already know about it, right? That is how you do it. However, you please understand that the mobility will be held constant at that particular point, because electric field is quite low. However, in a nanosheet, for example, this structure here, the electric fields are so large in these places that the mobility will not remain constant. Mobility will start becoming a field dependent mobility. For example, I am moving across the class. I will give you an example, right? I am moving across this class and I am moving very slowly. Then I will never get stuck within these walls because I am moving very slowly. But if I start moving very fast because of a large electric field, my chances of collision with the nearby chairs will be very large. So once I scatter more, the mobility starts to fall down. That's very logical reasoning, right? Mobility, current falls down, which means that at high electric field, I would expect to see a high current. I end up having relatively a low current because my mobility falls down. That is not accounted in a standard TCAD. So what we do, we take up this device, do its IDVD characterization using a B1500 Agilent sort of parametric analyzer, try to find out its IDVG. Once you know its IDVG or IDVD, then you try to correlate that with TCAD using tweaking your TCAD and putting the appropriate physics files in TCAD so that they are exactly matching with each other. This is more of a, I should say, a trial and error methodology we do. And then we reach this. Once we reach this, we freeze the TCAD physics files. We don't touch it after that. You got the idea? So this is how we do it, and this gate length and everything, we took it from a standard source. I will not be able to divulge that detail here, but we took it from a standard source. It was a mixture of ITRS and some data given to us by GF. Then what we did, this is one major problem which I want to highlight for NSFETs. And this is the problem of self-heating, right? Have you heard of, have you heard of, I'm forgetting its name, in BJT? Not tunneling, thermal runaway, yes. Have you heard of thermal runaway, all of you? Any one of you? So it is something like this. It's exact, not exact, but nearby. Your current increases, right? As current increases, I square into R increases. As I square into R increases, heat increases. As heating increases, more electron hole pairs are generated, more current increases. Again, I square R. So it's a cyclic process. A time will come when the current becomes so strong that your BJT will be broken away. BJT will be broken away. That is thermal runaway. What happens in a nanosheet FET is quite interesting. We run this simulation on ANSYS as well as on a Centaurus TCAD. And so this is basically Centaurus TCAD data. So this is a Centaurus TCAD data not available on Silvaco. So, and we found that there were hotspots coming up here, here, which means that at the drain end of the channel, the things were getting heated up. Can you tell me the reason, anybody in the class? Why we were seeing hotspots somewhere near the drain end? Because current was very, very high here. Your sort of current saturation was taking place here. At the source in the current, the electrons are moving slowly, right? But at the drain end, it will be so fast that the scattering will be so large that there will be large amount of heat or power dissipation taking place. And as a result, you will see these heating patterns coming. Orange ones are much more heated up. So this is a big problem, a big reliability problem. You might not appreciate it because this is a single device. When there are 10 to the power 6 devices per unit area, you can understand what the problem you are putting a chip designer into, right? And that's the one problem area. And the second important part is, unlike MOSFET, you do have a substrate on the back side. So yes, you see, there's a big substrate here. This substrate is a silicon substrate. Silicon is a bad conductor of heat. So any hot spots generated here don't get any place to go over as a heat sink. So the hot spots एक बार generate होना शुरू हो गया, you are done with it. You have to somehow or other remove it. You cannot do anything else. So that's the problem which you will face in this case. This is how you see at around 40 nanometers from the channel, we saw that the temperature was rising up. And you see the temperature, it's close to 370 Kelvin. And this is the temperature. If you, very layman wise speaking, if you put a thermometer there, you will actually see the temperature going to 378 Kelvin, right? And it goes on increasing. And this is with a moderate switching speeds. If you increase the switching speeds to gigahertz, this will further move up, right? I'm not going into details of that at this particular point, but there will be hotspots being developed. Okay, I'll just take one each, keep about 10 more minutes to finish it off. Is it okay? 10 minutes. So let me come to an NSFET, right? Now you see, quite interestingly, I'll go back and forth in this diagram and explain to you. You see, this is a spacer here. which is an oxide or a nitride. This is also nitride. So when you grow, you know why silicon came into picture? Anybody can help me, those who are students of electronics? Why silicon was the mainstay in VLSI? Right. Correct. So growth of native oxide over silicon is the most easiest technology or the process technology which you can take a silicon wafer, put it here, even here, wait for 10 minutes and you will have a small layer of white slimy layer of oxide being formed. So it's very easy. Same thing happens here. Since it's very easy, it comes with its own problem. And the problem is there are large number of traps which are developed in this region. What is this traps? It's something like this. You come to the class, what you will do, most of you will sit in the front row. If the teacher is good and you enjoy the class, you will all sit in the front row. Once the front row is fixed up, the second row will then get fixed up. Then the third row will come up, fourth row will come up, right? It's a very controlled process, provided your teacher is very strict and you have a good impression of the class. Take another scenario where the teacher is okay, he or she is not very strict, and you don't enjoy the class subject also, right? So what you will do, you will come here, 3 people will sit there, 5 people will sit here, 2 people will sit there, 7 people will sit there, and so on, and so you will scattered around the whole thing. What you do in the meantime, therefore, you keep these seats empty. Exactly same things happens here. The oxidation happens, not a very controlled oxidation, there are certain reasons for that, and then you generate these small seats at these particular points. These are traps. So what is the problem with traps? You will say, what is the problem, sir? The problem is now you're allowing these traps to act such that any extra electron coming from outside will first sit here and then they will go to the backside. So what will happen? You wanted the electron to come here and move away from that door. You just compare what I'm trying to say with this figure. You wanted the electron to come from the source side, move away into the drain side. But since you have traps created, these electrons start to sit in these traps. Because these are low energy states. And nature allows only low energy stability states. Agreed? Though what you do, you lose current. And therefore the reliability becomes a big problem. And that's what we have tried to study here, and graphs looks very complicated, but they give you an idea about what things are. It is generally degrading in nature, you will understand for that particular matter. For example, as you make the off current starts to fall down and so on and so forth. Okay, let me come to the last part, which is the impact of temperature with traps. And we saw that, and this is why we do it, because most of our requirements are military grade requirements, which require somewhere between 125 degrees centigrade down to minus 40 degrees centigrade is the range where your device should be stable, right? So we try to do that here, and we saw that as your temperature was increasing, we saw that our subthreshold slope was increasing. Which, can you give me what is subthreshold slope? Anybody? So I'll help you out. See, let me say the subthreshold slope is 60 millivolt per decade. What does it imply? It implies that if I do a 1 decade change in the gate voltage, if I do a 60 millivolt change in the gate voltage, I will get a 1 decade change in the current. The current was initially flowing at say 10 milliamp, now it will flow at 1 milliamp, right? So lower this value, better it is, because you will be able to switch the device very fast. However, with increasing temperature, you see what effectively your subthreshold swing is increasing. But good part is, and we are not very sure whether this result is correct or not, because this is not experimentally determined, is that your threshold voltage starts to drop down with traps, with temperature. We are not very sure. Please take this with a pinch of salt. I cannot, though this is my work and I'm claiming this is my work, I am not very sure about this trend. There are certain issues, other issues which we have not taken into account. But as of now, threshold voltage is falling and the subthreshold voltage is increasing. So basically, we are not in a win-win situation, we are in a win-lose situation for this device. I will not take the RDF into consideration. One thing which we did, and this is very, very important, I'll just take maybe 2 things and then I'll end the slide. Many times, especially in industry, not in academia, you are told to predict the EOL. What is EOL? End of lifetime. You know, say for example, you buy these bulbs, no, LED bulbs, 18 watt, 20 watt, so on and so forth, and they tell you that this will run for 5 years, 6 years, 7 years. So there is a dedicated team back in their Philips department or whatever company is there, which does an EOL prediction, end of life prediction. And therefore, if you take these FinFETs, if you take these Nanosheet FETs and plug it and try to run the show, then till how much time in stressed condition the device will work. That is known as EOL. And it has been seen that if you work with a larger thickness, the end of life is increased drastically to a larger value, right? And that is a good sort of good advantage which we get out of it. See, most of the time, 5 minutes. How much time is left, madam? We are already into lunch break. I know that. I'm so sorry. I'll take about 5 minutes and finish it up. I hope none of you are very hungry. No, must be hungry. Don't tell me. You must be hungry. You should be hungry. But try to stay with me for next 3 to 4 minutes. I will try to finish. Give you an idea and we'll finish. So the most allegation with device physicists and device engineer is that you only work with devices and you publish papers and you go home. So why don't we do a circuit design out of it? So we try to do a circuit design using a single stage common source amplifier using the Nanosheet FETs, and the results which we got was pretty decent. We got a voltage gain of 6.43 or 7, a decent terms in terms of this thing, but we were working with 0.65 technology voltage VDD, right? This can be increased slightly higher side. When you increase it to slightly higher side, this gain becomes larger. This is your input. The blue one is your input. The pink one is your output. And we got a gain of 6.43 using a nanosheet width of 50 nanometers, right? And this was quite decent work, which was done. So we had taken it from I don't know if you can see it or not, but IEEE TED 2022 Srinivasulu paper, and we modified that paper to get this value, and this was done on a DCAT platform. Similarly, we did it for NSFET to draw the noise margin. We did it for ring oscillators also, and we got a very good frequency of 30.75, right? But please understand, take it with a pinch of salt. I myself am saying it, though this is my word. This is not a post layout diagram. This is a pre-layout. Post layout, you will see sudden change here. It will drastically fall down, right? So all of you who are working in circuits, don't claim this result until and unless you have a post layout result where you have done an LVS, where the schematic has been actually converted to a layout stage, and you are able to extract the parasitic capacitances. And you will see, however, we foresee a fall of about 20% because of parasitic. This 20% fall complies to be 24-25 gigahertz. That's still a very good design which we are able to. So this is again from the TED paper. We were able to publish in one of our TED works later on. It is still the first review has been done. I will just take up one slide more and finish off this talk here. This is one device which is ahead of Nanosheet FET slightly, if you go by the Moore's law, and this is known as a Forksheet FET. This was actually given, so I told you, this person Mertens from IMEC Belgium was the person who first gave this idea, and this was first published in IEDM 2022. You can have a look at the paper. The TEM, I think I have the TEM with me. I don't know. I don't have the TEM. Maybe I will not go into details of all these things. It's quite complicated in a sense, but I will give you an idea what it's all about. So this is what a gate. This is N-type, so I have got N-type here. I have a P-type semiconductor here, and this is what is known as the dielectric wall, which separates N-type from P-type. Correct? So in one same silicon footprint, you are able to generate both N and P. And therefore, if I do a isolate, this is known as a closed gate technology, where I am using the same gate for N and P. I can also have an isolated gate technology, that I let this dielectric wall cross through this Forksheet, and I give separate VDD power supply to this side and this side, and therefore I can separately manipulate N-type and P-type semiconductors and generate a Forksheet FET, right? And that's what we have been doing it. We are in a very nascent stage of research. I cannot claim anything good coming out of it as of now, but we expect it will work fine. But industry is yet, it was done in 22, so industry is yet to take it up in a big way. Nanosheet is coming up in a big way, but Forksheet FETs, I would, if anybody is interested in this domain, go with slightly double check your results, triple check your results, because your TCAD is also not very well calibrated for Forksheets. One thing, maybe I will close the session, and so the challenges I will just not challenges, but yes, major challenges I will tell you what is in the Forksheet, where you can look as a research problem. And the three major issues is this dielectric wall is the first major issue. If this dielectric wall is not stable, not properly electrostatically isolating N and P, then these will start to talk with each other. Your EMI will be relatively larger, right? Your signal to noise ratios will be much smaller in that case. Your SNRs will fall down. So dielectric wall and its reliability is one major issue which you need to face, which you will face in coming days if you want to work in this domain. The second reliability problem is co-integration of nanosheet FETs and Forksheet FETs. A time is coming when you want to co-integrate these two together on the same wafer. Again, a very difficult task, and therefore collaborating with your people who are fabrication engineers or who are technology experts will be a good idea to move ahead. Self-heating effect with quantum computing coming up in a big way, a very good research area is self-heating effects, because quantum computing works at 4.2 Kelvin, 10 Kelvin to 4.2 Kelvin, your qubits work in that domain. If your cryo controllers don't work in that domain, you are in a mess. However, these are power dissipating elements because these are active devices, so you should appreciate that there should not be any self-heating effect, or even if it is there, it is very minimum. That's the third research area which is still an open question in a Forksheet FETs. Traps, of course, reliability is basic issue, and all these things are there. I will not go into all these details here. I will just stop here, and maybe there are many things which I thought of doing, but let me conclude to you what I discussed. Maybe I will just conclude within two or three sentences. We looked into nanosheet FETs and Forksheet FETs. I didn't go into FinFET knowingly because otherwise I wouldn't have gone through nanosheet FETs. I kept my Forksheet FETs also bare minimum because I am myself not sure whether that will be seeing the end of the day. But nanosheet FET, yes, surely that will see the end of the day, and fabrication will be possible. So with this, let me thank my collaborators here. Dr. Navjeet Bagga, he is in IIT Bhubaneswar, he is working with me. Professor Georgiev from University of Glasgow, we have some collaborative work in the area of Forksheets, not in nanosheets. So Navjeet works with me with nanosheets and Forksheets. Vihan works in the area of reliability issues in case of Forksheets. We have industry collaborations with GF, Intel and Samsung, and my colleagues at Roorkee, Avirup, Anand, and my postdoc Sunil has been also instrumental in making this PowerPoint presentation and correcting me whenever I'm going mistakes. So these are the person who generally correct me a lot. I go to them for my first cut. I don't understand anything, I knock their door and go inside. I say something, they say this is bullshit, you please go out of my room. I again do my maths work correctly, again come back to their room, they help me out. So I should acknowledge these collaborators for refining the work in the way which is currently today. With this, I will thank you all for your patient hearing, and if you have any queries, questions, I know you're all hungry, but if you have any queries, questions, how to move forward, suggestions, even suggestions to these slides, most welcome.
Any questions? Thank you so much, sir, for
Thank you,
delivering
thanks.
such an insightful talk on FinFET, nanosheets,